So this is the one of the questions at the MIT Integration B Finals 2023. It looks very benign and simple from the very outset, but it's a very difficult problem. So we'll attempt to solve it looking at the x to the power 4 plus x squared plus 1 component that can be broken down as the product of x squared plus x plus 1 times the square root of x squared minus x plus 1. Further, x squared plus 1 can be broken down as the sum of x squared plus x plus 1 over 2 and x squared minus x plus 1 over 2. So the x squared plus x plus 1 over 2 can also be expressed as square root to the power 2. And that allows us now to convert it into a binomial expansion of the two elements. So that allows us to remove this square root sign, and now we can have two separate elements, x squared plus x plus 1 over 2 and x squared minus x plus 1 over 2. Now we can separate this as two separate integrals of those elements, and we can dab the first component as integral 1 and the second element as integral 2, as encapsulated by the yellow and the blue rectangles respectively. The first integral as has been expanded, we can try to solve it by looking at the x plus 1 over 2 squared component and equating it to root 3 over 2 tan theta, so that we can factor out the 3 over 4 component, and thus dx d theta now becomes root 3 over 2 sec squared theta, and therefore dx is root 3 over 2 sec squared theta d theta. Now we can also look at the limits. Look, when x is equals to negative a half, tan theta becomes 0, and therefore theta is 0, the theta domain. And then when x is equals to a half, so a half plus a half means that tan theta becomes root 3 over 2 tan theta equals to 1, and therefore tan theta equals the reciprocal of root 3 over 2, which is 2 over root 3. And therefore theta becomes arctangent of 2 over root 3. And so now we can substitute the limits and the value of x by substituting in the theta component, which now allows us to integrate it in such a way that it's 1 over root 2 from 0 to arctangent of 2 over root 3, square root of 3 over 4 times square theta plus 3 over 4, and then we substitute in the dx value, which is root 3 over 2 sec square theta d theta. And now we can pull out the constants, which is through 3 over 4 root 2, and then the integral part becomes tan squared plus 1, which is equals to sec square theta. Square root of sec squared theta is sec theta, and therefore becomes 3 over 4 root 2, the integral of sec theta, sec squared theta, which is sec cube theta. So the way we can integrate sec cube theta is by splitting it into two parts and using integration by parts, where now we can equate sec squared theta to dv and sec theta u. Since dv equals to sec squared theta, then v is equals to tan theta. And since, again, u is sec theta, du becomes sec theta tan theta. That's the derivative of sec theta. And so knowing when tackling integration by parts that if u dv is the product on the left hand side, then the solution is uv minus the integral of v du. So by substituting that in, we get now the integral of sec squared cube theta is equal to sec theta tan theta minus sec theta tan squared theta, the integral sign. And then now tan squared theta can be expanded as sec squared theta minus 1. That now results into the integral of sec cube theta where sec cube theta can be also equated to the value I. So bringing sec cube theta onto the left hand side, we get 2I, and therefore 2I is equal to sec theta tan theta, integral of sec theta d theta. And so if I becomes half sec theta tan theta when we divide both sides by 2, plus the integral, half of the integral of sec theta. Let's now focus on sec theta. We can convert that and re-express it as 1 over cos theta. And by multiplying both the numerator and denominator by cos theta, we get the integral of cos theta over cos squared theta. By using the identical square theta plus sine squared theta equals to 1, cos squared theta becomes 1 minus sine squared theta. And then if we factorize 1 minus sine squared theta, we get 1 minus sine theta plus 1 times 1 plus sine theta. So that's at the denominator. Can also now separate those fractions into 1 over 1 minus sine theta plus 1 over 1 plus sine theta divided by 2, and so we get integration of cos theta over 1 minus sine theta plus cos theta over 1 plus sine theta. We integrate that, we get half of log or natural logarithm of 1 minus sine theta within the absolute brackets plus a half of log 1 plus sine theta. And using the law of logarithm, we divide 1 plus sine theta by 1 minus sine theta. If we multiply the denominator by 1 plus sine theta and also denominator by the same value, we get 1 plus sine theta squared over 1 minus sine squared theta. 1 minus sine squared theta now can be re-expressed as cosine squared theta. So we get half of log 1 plus sine theta over cos squared theta. Express everything under the squared bracket, therefore is 1 plus sine theta over cosine theta. If we now take the half on the left hand side up so that we get the square root of whatever is in there, and also by dividing, re-expressing 1 over cos theta as sec theta and sine over cosine theta as tan theta, we get that the integration of sec theta is logarithm of the absolute of sec theta plus tan theta. We use those absolute to ensure that we're taking the logarithm of positive values because that's where the result is defined. So sec cube theta when integrated is half of sec theta tan theta plus half of integral of sec theta, which is as shown in the derivation above, is half of logarithm absolute sec theta plus tan theta. Now bringing in our limits in from minus half to half in the x domain, which results into 0 to arctangent of 2 over root 3 of sec cube theta, we get that to be equal to 3 over 4 root 2 half of sec theta tan theta plus half of log sec theta tan theta from 0 to arctangent of 2 over root 3. So which is easy because when we pull the half outside, we get 3 over 8 root 2. And then we substitute in 2 arctangent of 2 over root 3, and then also 0 as shown here. Now sec in bracket arctangent of 2 root 3 equals to, as shown here, the square root of 7 over 3. So if we substitute square root of 7 over 3 into the previous equation, we get 3 over 8 root 2 times square root of 7 over 3 times 2 over root 3, because tan of arctangent of 2 over 3 just results into 2 over square root of 3, and then log of root of 7 over 3 plus 2 over root 3. And therefore that can be simplified into root 7 over 4 over root times root 2 plus 3 over 8 root 2 logarithm of 2 plus root 7 over root 3. So that's the result of the first integral. Then we can now attack the second integral in the same manner, where we equate the x minus 1 over 2 component to the same 3 or root 3 over 2 tan theta, such that dx d theta will be equal to sec 3 root 3 over 2 sec squared theta, and dx therefore is square root of 3 over 2 sec squared theta d theta. Now replacing the x's with the thetas, and also looking at the limits. First of all, when x is equals to minus half, tan theta is equals to minus 1, and therefore tan theta is, root 3 over 2 tan theta is equals to minus 1, and therefore tan theta is equals to negative 2 over root 3. And s theta therefore is equals to negative arctangent 2 over root 3. When x is equals to half, half minus half is equals to 0, therefore root 3 over 2 tan theta equals to 0, and therefore tan theta equals to 0. And theta therefore is arctangent of 0, which is equals to 0. So now just have to replace the x's with the thetas, and therefore the second integral now results into 1 over root 2, the integral of minus arctangent 2 over root 3 to 0 of square root 3 over 4 tan square theta plus 3 over 4 times root 3 over 2 sec square theta d theta, pulling out the root 3 both under the square root sign and also whatever is on the other side, results into 3 over 4 root 2 integral of minus arctangent 2 over 3 to 0 of tan square theta under square root sign times sec square theta. This results back into sec cube theta. And doing the same, applying the limits, also results into 3 over 4 root 2, and then pulling times whatever is shown there, pulling the half out results in 3 over 8 root 2 sec 0 times 0, logarithm of sec 0 times 0. Sec 0 is 1, tan 0 is 0, and log of 1 is 0. So the first component results into 0 minus, since we already derived the value of sec arctangent 2 over root 3, which is root 7 over 3. This time, it being negative doesn't matter because cosine of a negative value results into a positive value, but tangent of that negative arctangent results into minus 2, 3. So simplifying into root 7 over 4 root 2 minus 3, 8 root 2 log 7 minus 2 over root 3. So that's the answer for the second integral. Now summing up integral 1 and integral 2 to get the answer. Does require some further simplification. So as you can see here, it's the sum of x squared plus x plus 1 over 2 plus the integral of x squared minus x plus 1 over 2, all under square root sign. And then that equals to root 7 over 4 root 2 plus 3 over 8 root times root 2 log of root 7 plus 2 over root 3 plus 7 over 4 times root 2 minus 3, 8 root 2 log square root of 7 minus 2 over root 3. So the first constants add up into root 7 over 2 root 2. And then by using the law of logarithm, when we subtract, we're dividing under the log sign. And then if we multiply the numerator and the numerator by the same value of of 7, square root 7 plus 2, we get the square of root 7 plus 2 over root 3, and then we take half up so that we get the square root, and finally we get the answer as being root 7 over 2 times root 2 plus 3 over 4 root 2 log of square root of 7 plus 2 over root 3. And that's the final answer. Very interesting problem.